Hey everyone, so this is going to be the last video where we talk about radical equations. Remember, one of the things I said was that the steps are all the same. We're just going to look at some slightly more complex. In fact, one of them you'll see is going to be a little bit on the trickier side. So recall that we have these four steps. We isolate the radicals, we square both sides of the equation, we solve the equation, and then at the very end we have to check to make sure that we don't have any incorrect solutions. All right, so here's the first set. Now notice this is question 1 and 3 in the packet. I skipped 2, I'll get back to it later. So pause the video, work itself, and we'll go over in a second. All right, so to isolate this, we're gonna have to move the 1 over to the other side. So we have 3x minus 1 equals 2 root x. Then we're gonna square both sides. When we do that, we end up getting 9x squared minus 6x plus 1. That's what happens when we expand out that binomial term. And then we end up getting 4x on the right hand side because we have to square the 2 and then get rid of the square root. Once we do that, we then solve this like a quadratic by moving all the terms to one side. So moving the 4x over gives us, turns that negative 6x to negative 10x. Then from here, we just have to find a way to factor this. Again, as I said, all these equations that we're doing are factorable. So that's a nice way of making sure that you're on the right track. So when you factor this, it ends up being 9x minus 1, x minus 1 equals 0. If you forgot how to factor these types of equations, please look back into my previous videos on quadratics and factoring. From here, we get two solutions, 1/9 and x equals 1. So checking both of these, the first one we're going to check the 1 over 9. So we plug 1 over 9 back into the original. We get 3 times 1 over 9 equals 1 plus 2 root 1 over 9. When I do 3 times 1 over 9, this actually simplifies to 1/3. And then this, when I take the square root, I just take the square root of both the numerator and denominator, which gets me 1/3. So again, you can see that we're on the right track since we have similar fractions. So now I can do this. I multiply the numerator by 2 to get 2/3 and add 1 to it, which gets me 5/3. So from here, we actually see that 1 over 9 is not a proper solution because I didn't get a true statement. So let's just double check. Maybe 1 is going to be our solution. So I plug 1 into the original equation. I get 3 times 1 equals 1 plus 2 times rad 1. Well, that just becomes 3 times 1 plus 2, which is a true statement. Therefore, x equals 1 is a solution. All right, so for number 3, I do the same thing. I move the minus x over to get 3 plus x equals 4 root x. I take the square of both sides. When I expand the binomial, I get 9 plus 6x plus x squared. And on the right hand side, I get 16x. I subtract the 16x over to the other side so that my quadratic looks like this. I also write it in standard form. So you get x squared minus 10x plus 9 equals 0. This factors into x minus 1 and x equals 9. Setting both of those terms equal to 0, we find that the solutions will end up being x equals 1 and x equals 9. Checking my solutions, starting off with 1, I plug 1 into the original equation. I get 3 equals 4 times 1 minus 1, which is 3 equals 3. So far so good. Therefore, x equals 1 is a solution. When I do the same thing for 9, I plug that in. I get 3 equals 4 times root 9 minus 9. Square root of 9 is 3, so we get 3 equals 4 times 3 minus 9. 4 times 3 is 12, and that minus 9 is equal to 3. So that actually is also a true statement. So both x equals 1 and x equals 9 is a true statement for this original equation. All right, now we're going to do number 2. It's a little bit on the trickier side, so try it. I'll give you a hint. You will have to do these steps twice. So pause the video, work on itself, and we'll go over in a second. All right, so here we're not going to do the first step where we isolate the radicals because we actually have a radical on both sides. Now here's the thing. if I try to square both sides, the 4 squares nicely, it just becomes 16. But because there's this addition between these two radicals, that turns this into a binomial. So what I'm going to have to do is, just like with other binomials, expand this out and do my distributive process. When I do that, I end up getting root x minus 3 squared, which just comes down to x minus 3. Then I'm going to get 2 times root x minus 3 times x plus 5. And then on the right hand, and then plus x plus 5. And again, we have the 16 over here. So then from this, we're just going to clean some things up, combine the x minus 3 and the x plus 5, and we get 2x plus 2 root this stuff equals 16. You'll notice that all these terms are divisible by 2, so you can actually divide a 2 out from everything just to make life a little bit easier. Now we're going to do those steps again. We're going to isolate this radical term, so we're going to move the x plus 1 over to the other side to get 7 minus x. Now that the radical is isolated, we can square both sides. So it just gets rid of the square here. We get x minus 3 times x plus 5 and equals 7 minus x squared. From here, we can elongate and expand both sides. The left-hand side becomes x squared plus 2x minus 15, and the right-hand side becomes 49 minus 14x plus x squared. There's an x squared on both sides of the equation, so those actually drop out. And then we can combine like terms. Move the 14x over to the left, move the 15 over to the right to get 16x equals 64. And then dividing both sides by 16, we get x equals 4. Checking my answer here, I take the original equation and plug 4 into it. 4 minus 3 is 1, and 4 plus 5 is 9. So we get square root of 1 plus square root of 9 equals 4. This just simplifies to 1 plus 3 equals 4, which is a true statement. Therefore, x equals 4 is a solution. All right. And here's the last question. It's another application one dealing with triangles. So think back to what we know about right triangles, aka Pythagorean theorem, and try to answer these two parts. So pause the video, work yourself, and we'll go over in a second. All right. So what we're going to do is we're going to use Pythagorean theorem. Remember, that means when we take the two sides of this triangle, we take this side and square it, add it to this side and square it, and that should equal to this side squared. You might remember as a squared plus b squared equals c squared. I'm going to leave it in terms of like AB, BC, and AC. So AB is this side, BC is this side, and AC is the hypotenuse. So we're looking for AC. That's what the hypotenuse is. So I plug in 8 for AB, and I'm going to plug in x for BC. So I get 8 squared plus x squared equals AC squared. Because I want AC, that means I have to take the square root of both sides, so I get rid of this square on here. And I end up getting my equation as AC equals square root of 64 plus x squared. All right, so from here, then what they want us to do is figure out what the value of x is when AC minus AB equals 9. So what they want us to do is use this to figure out what AC is. So I know that AC minus AB equals 9, but I also know that AB equals 8. So that means I can plug 8 into AB to get AC minus 8 equals 9. Solving this, I find that AC, according to this, is 17. Plugging 17 back into that original equation, I get 17 squared equals 64 plus x squared. Then I'm going to square both sides just like I did in all these other ones to get rid of the square root. I then get 289 equals 64 plus x squared. Getting x by itself, I subtract the 64 over to get 225. And then I'm going to take the square root. Now, because these are supposed to represent lengths, I can only take the positive number. So remember, when we take the square root, for at least getting values like this, technically we get a negative number and a positive number. So I'm dropping the negative because the length can't be negative. It has to be positive. So I know x equals 15. Like always, we have to do one quick check. So I go back to the original equation. I plug 17 in that we knew of, and I plug 15 in for x. When I do this, I get square root of 289, which is a true statement. Therefore, x equals 15 is a solution. Like I said, if you ever go into higher levels of science, in particular physics, or higher levels of algebra, you'll be seeing things like this a lot. So again, that's why this is called the application of, when would you see it? Honestly, anytime you're trying to build a house or build anything, you typically need to make right triangles a lot in order to find lengths. So this actually does get used a lot if you plan on doing any sort of building or anything dealing with hand or construction. All right. If you have any questions, feel free to let me know. Otherwise, I'll see you later. Good luck and have a great day.